Hi, this is Jeff from Evans Tuning. In this video, we're going to talk about K-Series. Over the years, I've had tons of emails, phone calls, questions about K-Series related tech, and I decided to put a video together. This video is going to cover non-base model RSX, so we're not going to do the K20A3 motor or the new 9th gen K24 motors. They're kind of the oddball in the K-Series family. So we're going to focus on the Type S, the TSX, the 8th gen Civic SIs, or doing those engines in swap cars, Civics, Integras, whatever else you can stuff the K-Series in. So we're gonna go over all the pitfalls and some recommendations I have to keep the to keep your engine reliable, whether it's NA, supercharged, or turbo. So over the years, I get a lot of questions. What's the biggest bang for the buck I can do for my naturally aspirated K20, K20A2, K20Z, Z1, etc. So the Type S style cylinder head K20 motors. What I've seen: the RBC intake manifold, 3-inch cold air intake, a race header, and a 3-inch exhaust. They give the best possible power along with a tune. For that particular style motor. Now, if you have a TSX, so the K24A2 motor, doing the intake manifold on doing an RBC intake manifold on that engine actually will lose power if you're keeping the 25-degree variable timing gear in place. I've actually seen better overall power with the stock intake manifold keeping that stock VTC gear. Now, if you're going to upgrade the VTC gear to a 50-degree from the K20A2 motor, then you can go ahead and do the RBC, because then you'll see the gains being able to actuate the full movement of the cam angle to 50 degrees on the TSX engine. The next question we get for naturally aspirated K-Series is, I've done all the bolt-ons, I've gotten a tune. What do I do next? I want to make more power. I've found that most people's answers or most people's perception is, I'm going to do cams and I do valve train upgrade. Doing that will certainly make more power. On a stock engine, doing drop-in cam, you might get 10 to 15 horsepower. If you're gonna you want to do 100% drop-in cam that's 100% reliable, doing the 06 and newer TSX cams give the best power. Usually it's about 5 to 10 foot-pounds of torque and about 5 to 10 horsepower gain. They're a drop-in cam, nothing needs to be changed. If you're doing other aftermarket brand drop-in cams or upgrading to larger than a drop-in cam that needs a full valve train upgrade, you have to be aware that there is a potential for the timing chain tensioner to fail. The timing chain tensioner, unfortunately, is one of the pitfalls of the K-Series motors. I'll kind of touch on that a little bit later in this video, but once you drop in a non-OEM cam in a K-Series engine, you open up a can of worms for unreliability. So my personal standpoint, if you want to see 40, 50 horsepower gain without going forced induction, if you have a K20, is to K20 with the Type S head, take a TSX bottom end and drop your head on that and put that in the car. If you don't change anything else, so if you keep the same intake manifold, header, exhaust, you're going to see about a 40 to 50 horsepower gain and 40 to 50 foot-pounds of torque. So you'll have a broader, more usable power band. Typically, torque is 180 to 200 foot-pounds, and typical horsepower is 240 to 250 if everything else kind of remains the same. But you can't see that type of gain without going forced induction, and no set of cam is going to give you that much of a usable power and be 100% reliable. And that's the big factor here, is reliability. I'm not talking about making 30, 40 horsepower with a cam that's great, that it'll do that, but then the tensioner breaks a couple weeks later, a couple 100 miles later, and you're either rebuilding the engine or putting tensioners in the engine constantly. So we get a lot of questions about forced induction with K-Series, specifically supercharged. There's a couple options for superchargers. There's the root style kits. Jackson Racing used to make a kit with the M62 Eaton blower. That actually has been discontinued as far as I know. Comptech sells the root style blower kit. And there's also the Rochex style kit from Craftworks. that's available as a bolt-on for the 8th gen Civic Si and as well as the 9th gen. When you're going supercharged, I get this question all the time. People want to do cams, so they make whatever power they make and say, I want to do a cam that's going to make more power. With the Roots style blower kits, so the CT and the Jackson kits, don't upgrade the cams. Leave them OEM. You will lose power. If you want to upgrade, put the 06 TSX cams in because they're drop-in and they might give you a slight increase in power, but for the most part, just save your money, keep the stock cams. Now, going with a Craftworks kit, you can do cams. Usually a mild NA drop-in cam will work. However, keep in mind that once you do a cam upgrade that's not OEM in the K-Series motor, that you're more likely to have tensioner failure. So if you're trying to go about this as, from a reliability standpoint, stick with the stock cams. And another point I kind of want to touch on is, I did an S2000 tech video, and the S2000s are a little unique where the header and exhaust design is really, really good from Honda. Now the K-Series isn't like that. It's you need to do your normal upgrades that you would have NA. So with the Roots kit, the supercharger is mounted on the intake manifold side, so your intake manifold isn't going to be upgraded. So on the Roots kit, I find doing cold air style intake is beneficial. Doing a larger throttle body is beneficial. Doing the normal race header, so you get rid of the cat, and a 3-inch exhaust, that combination will make the most power. Also on the Root style kit, because they're non-intercooled, there's kits available that add an aftercooler that it's a inline heat exchanger that goes between the blower and the intake manifold, and it has a water pump and it circulates water with a heat exchanger up front like a radiator. That is typically good for 20 to 30 horsepower, and it keeps the power consistently at the same level, where if you didn't have that, it would get a ton of heat soak, and then it would, it's going to lose power if you get on it a couple times. So that's another kind of thing to keep in mind with the Roots. With the Craftworks Rotrex style kits, doing the typical bolt-ons that you would have NA would apply to that kit because the supercharger is mounted on the side of the motor, and it has traditional piping like a turbocharged would, but you have your header and exhaust in place. So if you're going to do an upgrade for the intake manifold, doing an RBC, if you're a swapped car that's not an 8th gen Civic Si, doing the RBC intake manifold is worthwhile. If you were an 8th gen, you already have the intake manifold, and then just doing the normal race header and exhaust is all you would need because the kit comes with everything else. So if you're thinking about going a turbocharged route with your K-Series, there's a whole bunch of things that you kind of cover and you need to know. First, the K-Series motor is like the S2000, it's also like the other Honda motors, that it's sensitive to exhaust back pressure. So putting a log-style manifold on a K-Series is going to kill power, just like it would on an S2000 or a B-Series motor. Doing a tubular-style manifold will make substantial increase in power over a log. So you're looking at anywhere from 50 to 150 or possibly more horsepower gain from going from a log to a tubular style, as well as decreasing the knock sensitivity of the engine. So you're allowing the engine to breathe. You'll be able to make more power on the same octane, and the engine will actually run much safer with the additional power. Now, doing a tubular style manifold on a K-Series is the same kind of situation as an S2000. You run into boost creep. So you need to make sure that your wastegate size is adequate for the turbocharged size that you're running. There's a lot of technical stuff that we can get into. I'm trying to keep it relatively straightforward. If you're running a GT30R or smaller size turbo, in general, I have seen that you can get away with a 44, a Tile 44 MVR style wastegate that'll adequately bypass enough exhaust flow from the manifold to regulate the spring pressure that you're trying to run. So if you're trying to run an 8-pound spring in your wastegate and not creep to say 20 pounds, you don't want anything less than a 44. If you're running something larger than that, you're either going to need 2 wastegates, so either 2 44s or 1 large 60 millimeter. From a packaging standpoint, it's a little bit of a pain in the butt. but you don't want to get into the situation where you get massive boost creep, you can't control the boost, per gear, or you literally can't control the boost on pump gas, and you won't even be able to rev past 7,000 because you'll boost creep to 30 pounds or something ridiculous. That'll blow the engine. So that's you got to keep that in mind, when you turbo it. But I always recommend doing a tubular style manifold. There's a bunch of great manifolds out in the market. You want to avoid, the cheap eBay brands like, SS Autochrome if they're even around, or, thin wall, crappily welded manifolds that are going to crack and create problems. You want to stick with quality brands, Full Race, Sheepy. There's probably many more that are out there that have a warranty, that are thick wall, that are meant to actually last and not fall apart. So you want to look into some quality from a reliability standpoint. So I want to kind of talk about the strengths of the K-Series motor with forced induction. The cam profile design OEM is really, really good. A lot of people always want to upgrade. Coming from other engines, doing cam upgrades gives a lot of power. And K-Series can certainly benefit from a larger cam, but you have to keep in mind from a reliability standpoint of having tensioner failures, keeping the stock cams can meet power goals that people probably don't realize that you can make with a stock cam. I've made into the 900 something horsepower range with stock cams. It probably can make more. The cam really isn't a limiting factor. Can you make more with a larger cam at less boost? Yes, you can. But you're opening up a can of worms again with having the timing chain tensioners fail and having an unreliable motor in that sense. So you got to keep that in mind. Another strength of the K-Series, unlike D, B, and H series, is the factory sleeve design is very thick. I've made into the 900 horsepower range with the stock sleeves. Doing sleeving is always, if you can afford it, is always a good idea to do it. So, if you have the extra cash and you want to spend, making it ultra reliable, doing sleeves is always going to be stronger than the stock sleeves. However, the K-Series sleeve is much, much thicker, much better designed block than the B-Series, for example, because everyone's familiar with the B-Series. The B-Series sleeves can handle 500, 600, 700 horsepower. They're hit or miss. I've seen them last, I've seen them not last. The K-Series, typically you don't see the sleeve crack. You'll see the piston crack the ring lands before you'll see the sleeve actually fail. So, if you're looking to do a 600, 700, 800 horsepower build, from my point of view, if it was my personal car, I probably wouldn't sleeve it. I would just do pistons and rods and keep it simple. And if you want to really push the envelope down the road, sleeve it so you don't have to think about it. Or if you have the extra cash and you don't care and you just don't want to do it twice, then cool, then sleeve it. But you don't absolutely need to, like a B series or some of the older Honda motors. So one of the most common issues on a K-Series motor is the timing chain tensioners, or TCT. I've talked about it a whole bunch in this video already. Now I'm going to kind of walk you through why you may not want to upgrade your cam and have any issues. So upgrading cams makes the engine more unreliable because the TCT is more prone to fail. Putting a larger cam in the engine is going to make more power in general because you're letting more air into the engine. When the camshaft profile design, there's a thing called a ramp rate. So it controls how quickly a valve opens, how long it stays open, and then how quickly it closes. In that design, there's an engineering term called jerk, which is the relationship of what's going on there. To keep it simple, every camshaft design, even OEM has this term called jerk. It has a measurable amount. That is what causes the TCT failures. Some camshaft profile designs have it much worse than others, but in general, sticking any aftermarket cam in a K-Series motor is going to make the TCT more prone to fail. There are some solutions to this. There's several different aftermarket options available for upgraded TCTs. However, they can and potentially will still fail. the best option I found from all the aftermarket TCTs is from Inline Pro. They make a modified OEM. They change some of the internals out, and that seems to hold up the best that I have found building K-Series and tuning K-Series motors over the years compared to the other options. But still be aware that doing cams can and will make the engine less reliable. And if we're talking about reliability here, you know, making power is great, but being able to turn your car on every day and drive it without having to worry, you know, you need to keep that in mind with putting a large aftermarket cam inside your engine. So I just touched on the TCT failure and all the ins and outs of that. So there's a lot of other issues that I see tuning and building K-Series engines that I want to kind of touch on to make everyone aware of. The throttle position sensor, or the TPS sensor, is another known failure point on a K-Series. When you do a swap, or if you put stiffer aftermarket engine mounts, you're going to get a lot more vibration in the chassis, also into the engine. The design of the factory TPS sensor can't handle that vibration. So the sensors fail, which causes the deceleration fuel cut to turn on while you're driving, makes the car really jerky. You're going to get a lot of stuttering, bucking, whatever you want to call it, and you're going to have to replace the TPS sensor. You can't purchase the TPS sensor from Honda. You have to buy an entire throttle body. There are several aftermarket solutions from companies. However, those fail as well. I have not seen one particular design last. The best solution that I've came up with, K-Tuned, and I think there might be another company, makes a B-Series a TPS adapter. So you can take a B, D, or H series TPS sensor and bolt it on with this adapter to your K-Series throttle body. The B, D, H series TPS sensors are not sensitive to engine vibration as badly as a K-Series. In general, you can go purchase a used D-Series throttle body for $20 off eBay, take the TPS sensor off, buy this adapter, bolt that on, and that will solve all your issues. So if you have a swap car, or if you have a 8th gen or 9th gen Civic that has a returnless style fuel system, a lot of people incorrectly route the fuel pressure lines, fuel pressure regulator lines going in their car. So they try to use a pass-through style with the regulator where the feed line passes through the regulator and then it goes into the fuel rail, but there's no return. There's only a feed. So let's call it deadheading into the fuel rail. That's the way that it would be stock on a returnless style system, because there is no return line. That severely limits what the fuel system can handle as far as power. It also improperly lets fuel flow through through the fuel rail on a high power engine when you're trying to feed injectors, make a bunch of power. The other issue that I see is a lot of people don't run a vacuum line from the regulator to the intake manifold for vacuum reference. This is super critical on a forced induction application, turbo or supercharged. You need to have a one-to-one reference, so the fuel pressure needs to rise 1 pound to overcome the pressure in the intake manifold that's rising 1 pound. So if you don't do that, you'll make substantially less than you would doing a one-to-one reference with the vacuum line. So if you're going to do your fuel system, do it the traditional style where you're going to have a feed coming into the fuel rail, you're going to have your return leaving the fuel rail into the regulator, and then out the regulator back down to the tank. You don't want a deadhead. You don't want to come from the fuel tank up into the regulator, from the regulator to the fuel rail, and then not have a return out of the rail. I see people do this all the time. It is incorrect, and it'll limit what kind of power you can make on a given fuel injector size. The variable cam timing solenoid that's on the K-Series motor is prone to have issues with higher mileage. I've seen now in the last year maybe a dozen K-Series cars that I've been tuning that have 100,000 miles or more have bad variable cam solenoids. So that's what controls your variable cam timing gear movement. I've had issues where the solenoid itself has been bad and needs to be replaced, or I've also had issues where there's a solenoid screen up on the cylinder head. If you're standing in front of the engine, it's off to the left. It's a little plate that has 2 bolts holding it. It's a little mesh screen that can be serviced and cleaned or replaced. If that solenoid screen gets dirty, it's just like a VTEC solenoid screen. It limits the amount of oil pressure that's going to your solenoid, which then limits the amount of control that the variable cam has. So first, before you replace the variable cam solenoid, you want to check that screen and make sure it's clean. If it's clean, then the next thing would be to replace your variable cam solenoid. You're going to know that it's a problem if you're looking at, let's say you're running K-Pro, if you're looking at your cam command of say 30 degrees and you're only achieving 10 or 20, or you're getting unstable cam timing where your cam timing is constantly moving around when you have a constant target, say if you're steady state driving. And as soon as you see that, you have something going on with the solenoid or the screen being dirty, so keep that in mind. So another area of concern on a K-Series, specifically the 8th gen Civic SIs, is they have a oil pump with balancer shafts in them. That oil pump design can't handle high RPM. So if you're going to rev that engine much over 8,600, you're going to need to replace the oil pump. The RSX Type S oil pump from a 02 to 04 RSX Type S, which is the K20A2 engine, that oil pump is a drop-in fitment and won't have the issues of revving up to 10,000 RPM. That leads me into another kind of topic here. The other upgrade for a K-Series engine is the S2000 oil pump with some machining options. I think ERL sells it. I'm sure there's some other people that have that on the market. The S2000 oil pump moves a little bit more. It's a higher flowing oil pump. It is an option to upgrade. If you're building the engine, you're going to see a super high RPM. If you're building a race engine, it's going to see like 10,000 RPM, or a road race car. That oil pump does put out more in its OEM, so it is an option to upgrade, and it may or may not need it. It's just kind of up to what you're doing with the car. Over the years of building and tuning K-Series engines, I've seen several different failures. The one that's not most common, but I've seen it maybe 20, 30 times, the factory OEM rocker assembly is a roller style rocker. For whatever reason, I see them, they get hairline cracks, or they crack and break. So it can be avoided if you do regular inspections, every maybe 1,000 or 2,000 miles. If you have a larger aftermarket cam in, you're just going to want to look on the roller rocker and spin it all the way around to make sure you're not seeing any hairline cracks. If they are cracking, you want to replace them. If they break, it ends up being a mess. It can jam a rocker up. It can drop a valve. It can break a retainer. So you want to kind of keep an eye on that. So if you have an aftermarket cam, it's more critical to keep an eye on that as a maintenance item, just to keep an eye out for. So when you put an aftermarket clutch in any engine, it's going to have a higher clamping force on your pressure plate. What that means is when you clutch in, there's more force that's applied on your crankshaft. When the engine is cold and there's not oil pressure built up, there's a thrust shim. There isn't adequate oil supply to that thrust shim on cold start. So every time you push your clutch pedal in with a higher pressure plate clutch, an aftermarket clutch, you're basically putting metal on metal contact. You're going to have obviously some oil there because there's oil in the oil pan, but there's not oil pressure built up on that surface. So what ends up happening over time is you wear out the thrust shim. The higher the pressure plate clamping force in the clutch, the quicker that can wear out the thrust shim. On any aftermarket clutch, I always recommend to take out the factory clutch switch so that you don't have to clutch in on cold start. You have to be mindful to keep the car in gear, or the car will jump forward as you're trying to start it. But eliminating the clutch switch will eliminate the potential for the thrust shim to fail. So another weak link on the K-Series is the transmissions. Specifically, I've seen the most failures with second gear. Also with doing high RPM fast shifting, the shift selectors actually get bent. Unfortunately, there is no solution for second gear failure. There are some gear sets aftermarket that seem to help the first, second, the second gear be a little bit stronger. So that is an option to upgrade. And there are shift selector upgrades. I believe Speed Factory is one of the people that make the factory selector upgrade that makes it stronger. So if you end up running into those, there are aftermarket solutions, but they can and will break OEM. And if you're replacing them with OEM parts and you're not making them stronger, they're going to fail at some point again and going to have the same exact problem. So if you have an RSX or an 8th gen Civic Si, you have a returnless style fuel system in your car. If you're going forced induction, the limit of the return style fuel system with upgraded injectors and an upgraded fuel pump in the tank is about 450 horsepower. That's with a 1000 cc and like a 255 in the tank. That's give or take. I've seen them as low as 400 and as much as 450. You don't even want to approach 450 with the returnless style fuel system. So if you're going to make more power than that, you need to do a return style fuel system. So you need to add a return line, a fuel pressure regulator, and an aftermarket fuel rail in order to convert the returnless to return style. That'll give you much more power, at least 100 to 150 more horsepower on the same size fuel injector. Also, when you do it, you need to make sure you run a vacuum line from your intake manifold to your fuel pressure regulator so it rises your fuel pressure 1 psi for 1 psi of boost increase. If you don't do this, you're substantially limiting yourself on what the fuel system can support. So if you've done a swap in a Civic and Integra or something else with a K-Series motor and you haven't upgraded the clutch and flywheel, the stock clutch and flywheel can technically hold what normal bolt-on modifications will produce for power. I have seen now multiple times over the years where someone has bought a used swap and they haven't changed out the clutch and flywheel. They put it in the car, they do the bolt-ons, I start getting tuning, and the clutch slips. Because the car either had a ton of miles or it was abused, in the previous car it came from, which would have been an unknown history to the person that's doing the swap. So if you can afford to do it, I would upgrade the clutch and flywheel. Now, if you're going forced induction, supercharged turbo, nitrous, you're gonna want to upgrade the clutch. The factory clutch is not going to handle it. If you're going to swap in a K24 bottom end, then you're going to want to upgrade the clutch. You just don't want to be in the position of, you do all the work, you swap all your parts on, and you go to the dyno and your clutch slips. So you want to, if you can afford it, do the clutch and flywheel. You also have to keep in mind that you want to do more clutch than what you need. Like a competition stage 2 is good for your normal bolt-on car, a K24, or a root style blower car. If you're gonna do, a Rotrex kit or a turbocharged, and you're gonna look at, a stage 4 or a 5 or a twin disc that can handle much more torque capacity. But you're gonna compromise some drivability going with a higher sprung clutch. So that's, it's a factor you have to keep in mind. So that's it for a K-Series tech video. All my opinions in this video are based on reliability, not so much making the most amount of power. There's multiple different ways to do the swaps, to do the power upgrades. I'm sure there's going to be people who watch this that don't agree with what I've said, but from a reliability standpoint, and having done this for the last 8-10 years working with K-Series motors, that's what I've seen. This is what I've seen be the most reliable or unreliable out of the K-Series. So there's a lot of things to keep in mind, but in general, if you want to have a reliable K-Series swap, car, whatever, pay attention to everything said in the video and you'll be good.